Hey, this is Coach Latham, your math coach, and today we're going to talk about an important topic in algebra, graphing linear equations and inequalities, and we're going to try our very best to get this done within 15 minutes. The first thing we're going to talk about are intercepts and slope, and I've already have an entire video devoted to slope, so please make sure that you've watched that one before this, and that will help clear up a lot of things. In this one, the graph on the left, we're going to identify the x-intercept and the y-intercept. The x-intercept is the point in which the line crosses the x-axis. In this case, it's right there. So we're going to say this has an x-intercept of -3. It crosses the y-axis right up here at the 2, so we'll say that it has a y-intercept of 2. I do want you to know that there is a special symbol that stands for y-intercept, and that is b. So for this one, we would say that b is equal to 2. Taking a look at the graph on the right, we're going to identify the slope. To get from this point on the graph to this point on the graph, we go down 2 steps. So it's going to be -2 on top, and we go over 1, 2, 3, 4, 5. So we've got a 5 on the bottom, rise over run. So the slope is -2/5. Again, if you're confused by that, go back and watch the slope video. All right, so the slope-intercept form of an equation is when the equation is in the form y equals mx plus b. This is the one that we like to use, and it's also the one that your calculator uses, so this is the most important one for us to know. Taking a look at this example over here, we've got y is equal to 3x minus 4. What that means is just by looking at this, we know that the slope is 3, because the slope is that number in front of the x, and we know that the y-intercept is -4. So just based on this, we know that this line crosses the y-axis at -4, and from there it goes up 3 over 1, up 3 over 1. So we already know what this line looks like just looking at the equation. It says name 3 points on the line. We could name as many as we want to. For every value we put in place of x, we're going to get a corresponding value of y. So let's say that x is 10. If x is 10, then it's going to be 3 times 10 minus 4. And 3 times 10 is 30. 30 minus 4 is 26. So when x is 10, y is going to be 26. We could pick another one. Let's say x is 2 for the sake of argument. And this time we're going to have a 2 in place of the x. We're going to have a 2 right there. So it's going to be 3 times 2 minus 4. Well, 3 times 2 is 6. 6 minus 4 is 2. So y would be 2. You can pick as many points as you want and just keep on going, and we will move on. We're going to write the equation for the line. I got for the line. That's bad grammar right there. Fortunately for you guys, I'm a little bit better at math than writing, although maybe not that much. And we want to write the equation for this line. The first thing we're going to do is find the y-intercept. The y-intercept of this line is right there. So we know our equation is going to be y equals something x plus 4. 4 is the y-intercept. The only thing we don't have in here is the slope. From here we go up 2 over 1, up 2 over 1. 2 over 1 reduces to 2, so our final equation for this line is going to be y equals 2x plus 4. Got an exercise. Oh, no, we don't. We're going to graph the following 2 equations on the coordinate system. We're not going to take a whole lot of time doing this. The first one has a y-intercept of 2. Put a dot at 2. It's got a slope of 3/4. That means we're going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. Connect the dots. And we got the first one done. Let's go ahead and do the second one. Has a y-intercept of 2. Well, that's the same spot right there, but this one has a slope of -3, so we're going to go down 3, 1, 2, 3, and over 1. When it's an integer, it's over 1. So here we go. We have graphed those 2 lines. The next one is for you to do. Go ahead and hit pause and then drag or identify each of these equations, match them up with the 4 graphs. Hit pause right now and give it a try. Okay, we're back. I've got them all matched up here for you. Check yourself, see if you got them right. This one right here has a y-intercept of 2, and it's got a slope of 2/3. We go up 2/3. There we go. This one right here has a y-intercept of -2, and again a slope of 2/3. You go up 2/3. This one down here has a y-intercept of 2, got a slope of -2/3. We went down 2/3. And this one had a y-intercept of -2, and it went down 2/3 from there. So that's pretty easy to match up. Although my graphs are not exact, it should be simple to tell which ones were the best fit. Now, we've got an SOL question here from a few years ago. It says, for the equation y = 2x + 5, which of the following ordered pairs are on the line? In other words, the solutions to the equation. Plug those in and give them a shot real quick and hit pause. All right, I'm back. We're going to work these out together. To help myself, I'm just going to put the equation under each ordered pair to kind of keep me straight. What you would want to do is write the equation under each ordered pair. And we're just going to put y in place of y. So 11 goes in place of y here, and 3 goes in place of x. 2 times 3 is 6. 6 plus 5 is 11. We get 11 is equal to 11. That is a point on the line. We do the same thing right here. We're going to put 5 in place of y. We're going to put 1 in place of x. And 2 times 1 is 2. 2 plus 5 is 7. 7's not equal to 5. I'm sorry, you fail. We'll do the next one. We'll put 5 in place of y. We'll put the 0 in place of x, and we'll check it out. 2 times 0 is 0. 0 plus 5 is 5. 5 is equal to 5, so that point's on the line. And the last one, we'll put a 25 in place of the y. We'll put the 10 in place of the x. And 2 times 10 is 20. 20 plus 5 is 25, so that one is a winner. 25 is equal to 25. We've got 2 more tough questions here, like you might see on an SOL test. The first one says, write the equation of a line with a slope of 3. Bing, bing, bing. I already know that y is equal to 3x plus something because the slope is 3. What I don't know is the y-intercept, but they give me a point on the line, and since they give me a point on the line, I can solve for b. I'm going to put 5 in place of y and 1 in place of x. So it's going to be 5 is equal to 3 times 1 plus b. I'm sure you already know the answer in your head. B is going to have to be 2 here. Now, since b is 2, and we already knew that the slope was 3, we can go straight to our final answer. Y is equal to 3x plus 2. So, although that's a tough question, if you understand how these things fit together, you should be feeling pretty good about it. The second one is, has an extra step. We've got to calculate the slope using the slope formula, and then we're going to do it the exact same way. Go ahead and give this one a shot on your own. Okay, I've got this one worked out for you. You could hit pause again and just check your answer if you'd like. I've got the slope formula over here where I subtract the y's on top and the x's on the bottom. I get -4 over -2, and that reduces to 2 for the slope. Again, go back and look at the slope video if you're having a hard time with the slope formula. We then know that the slope is 2, so we've got that part of it done. We can pick either one of these 2 points and plug it in to solve for b. I went ahead and used this one right here. So I put 2 in place of y. I put the -1 in place of x. I work it out and I solve for b, and I find that b is equal to 4. Now that I know the slope and I know the y-intercept, I can go ahead and write my final answer. Y is equal to 2x plus 4. We've got 2 special equations to cover, horizontal lines and vertical lines. Anytime it's a horizontal line, like this one, like the blue line on here, then you're going to have y is equal to something. That means that the height of this line never changes. It's always 4. So the equation of that line is y equals 4. And then the equation of this vertical line right here is going to be x equals negative 5. X stays the same. That's why it's a vertical line. And x is always negative 5. Vertical lines, x equals something. Horizontal lines, y equals something. We're going to shift gears for a minute. And this little crazy diagram here helps me with graphing inequalities. Graphing inequalities is just like graphing lines, except you have to figure out whether it's a solid line, a broken line, shaded up and shaded down. If it's a less than, then it's going to be a broken line shaded down. If it's a greater than, then it's going to be a broken line shaded up. If it's a less than or equal to, the line itself is part of the answer, so it's a solid line shaded down. And if it's a greater than or equal to, the line is part of the answer, and it's a solid line shaded up. So that's what you need to remember. Take a look at this graph right here. We know that y is in a relationship with 2x. We just want to know whether we're putting in a less than, a greater than, a less than or equal to, or a greater than or equal to. Well, this is a solid line, so the line is part of the answer. It's going to have an equal part, and it's shaded down. So this one is going to be y is less than or equal to. Solid line shaded down. We've got 4 inequalities right here. I'd like for you to hit pause and try and match them up with the inequality equations, or the inequalities at the right will match with their graph. All right, I got your answers up here for you. We got a boundary line of y equals 5 on this one, and it's a solid line shaded up, so it's y is greater than or equal to 5. This one's a broken line, so it's got to be either less than or greater than. It's shaded down, so this is a less than, and the boundary line is y equals 5x. Broken line shaded down. This one is one of our special equations. We've got x is less than or equal to 5. Well, the boundary line is x equals 5, which is this vertical line here. It's a solid line shaded left because that's where x is going down. No problem there. And then the one on the bottom left, although it's kind of caught up in the waves here from the line, y is greater than 3x minus 5. The boundary line is y equals 3x minus 5. Greater than means a broken line shaded up. So we should be good to go right there. All right, the next thing we're going to talk about is graphing equations that show up in standard form. Sometimes you'll get an equation in this form right here, 2x minus 3y equals 6. It's pretty easy to get it graphed. You're just going to act like y is 0, and you're going to forget about that minus 3y, so you just take this piece and say 2x is equal to 6, and then you'll divide both sides by 3, and you get the x-intercept is 3. And then you suppose that the 2x part doesn't exist, or x is equal to 0, and you get negative 3y is equal to 6. And so when you divide both sides by negative 3, you get the y-intercept is negative 2. This doesn't come up that often, but every once in a while it will. So go ahead and hit pause, break this into its 2 pieces and graph. Okay, I'm back. So the first thing we're going to do with this equation is suppose that the 3y doesn't exist. In other words, y is 0. So one of our equations is going to be 4x equals 12. The other equation is going to be what happens when we ignore the 4x and just say that 3y is equal to 12. Now when I work these out, I'm going to get my 2 intercepts. In this equation right here, I'm going to divide both sides by 4, and I get my x equal to 3. Since y is 0, this is my x-intercept equals 3. And so I can put a dot right here at my x-intercept is 3. I'm going to come over here and do the same thing with 3y equals 12. I divide both sides by 3, and that gives me y is 4. Since I know x is 0 here, then this is my y-intercept, or my b. b is equal to 4. I'll put a dot right here. Once I have 2 dots, I can connect my 2 dots and get a line. This has been solving, writing linear equations and inequalities in under 15 minutes. And although I spoke very quickly to get here, we are at the end. Please make sure that you go back and have looked at the slope one, and then we're going from here into rewriting equations, so that will be your next video. Good luck, keep studying, be great at math.